Hello, civil engineers. Welcome back to the lecture. So here I'll give you a lot of assignments, and also I'll be explaining a few of the complicated footings where you can take out the BBS. The method remains the same, but still, since I take a lot of assignments, so that you don't find any problems in future, we'll try to take that. So all these drawings I've already given you. I hope you have downloaded that. And if you remember, we had taken the quantity estimation for this footing as an assignment. Now for the same footing, you see, this time the reinforcement is given. Okay, what is written here? Raft bar in bottom, that is reinforcement bar in bottom, 12 diameter at 155 center to center spacing, and bar in top, that is both ways. Okay, now here what has happened, see here, this is actually a kind of isolated footing. If you observe here, it's isolated footing only. Why? Because there's one column and there's one footing, so it's isolated footing. But here, like I told you, all the isolated footing will not have only the bottom reinforcement. There's every chance that may have your top reinforcement. So when this situation comes, usually when you have a industrial structures and all, that means you're putting a RCC substructure. Over that, a steel structure will come, like your column, the steel column, the purlins, the rafters and all. Due to the wind load and all, there may be uplift and all. Sometimes because of that reason, we give the top reinforcement also. And if you don't give the top reinforcement, that column may punch your this thing, that footing, and it may bulge in this way, this portion. That is why in order to take care of that, minimum reinforcement will be given in the top also. So that is why if you observe here clearly, see, the bottom reinforcement is given, which we usually give in isolated footing, and then the distribution bar. But similarly on the top also we have given. This is actually a case of a combined footing, but it is not combined footing because you have one footing and one column. But I explained the reason behind that. Okay, so that is the reason you see you get a reinforcement here. It's written in the bottom and they write both ways. Now they see, they don't give a column. All the drawings you will not, it won't be like you think. Usually what is mentioned here, both ways, it means shorter span and longer span. This is in bottom. Okay, this is for the bottom. Similar, this is for the top. Again, both way means top shorter and top longer. Both way means bottom shorter and bottom longer. Few people, instead of writing in this way, they would have made 4 columns. Like this is for the shorter bottom, shorter longer. Then again for the top shorter, top longer. This they would have done. But here this person has not given. Now you can do the BBS for this. Very simple. This BBS, whatever you are going to do, it's similar to the Excel sheet what I've taught you here. This one, the combined footing I taught you, same thing. This is how your BBS should look. So your bottom shorter will come, bottom longer will come. Then again your top shorter will come and top longer will come. Okay, nothing will change. If you want, we can do that also. I'll just input these values and you'll get the answer. Okay, so let me do that quickly. Okay, so it's written. Okay, first you have to mention the size of your footing. So it is 2900 by 2900. Just input here. I'll input here 2900. Okay. Yeah. 2900. Done. This is also 2900. Okay. Finish. Okay. Then what is the depth of your footing? So depth of the footing is 500. So input here 500. Done. Finish. So accordingly, you see, you got this reinforcement. Okay. You got the this. Okay. Where did I put? Wait. It has gone to the top. No. It should come here, not there. Yeah. Here it should come. This is that footing. Okay. How much it is? 2900. 2900 and 2900. Okay. And depth is 500. So depth is 500. This is done. So you got the answer here. Your cutting length 2900 minus left side 50, right side 50 will be minus 100. So 2900 minus 100 is 2800. You know that. Same by default, you got the answer. And this depth also we know. 500 minus top cover minus bottom cover into 235 do. Same thing I have done. You got it as 267. Got it? Fine. Now come to the reinforcement part. So reinforcement has written, you're supposed to make use of 12 diameter bar. How many F1 footings are there? So number it's not mentioned. Will for our understanding, I'll take only 1 year for time being. Okay. And what is the reinforcement? 12 diameter. So input 12 here. Input 12 here. Input 12 here. Okay. Fine. And it is 155, 155. So it was earlier I had put 150. You make it as 155. Okay. And here also you make it as 155. Done. Where did I do? Along the bottom I did. I want top also. This is top reinforcement. Similarly, come here. Top also you change. So once you change here, automatically this part also will change. Only the thing is you have to change this part now. Okay. This is 12 diameter, no? Make it 12. This is also 12. Why? You know the reason, okay? 12, 12. And what is the spacing in the top reinforcement? See, it's top written in both ways, shorter and longer, it is 175. So I'm making 175 here. I'm making 175 here. Finish. Done. Okay. Accordingly, you don't have to do anything. You got the answer. Total 20 bar is required. Here 20 is required. And in the top, you require 18 and 18. Why the okay? Why this becomes 17 then? This is 18. Okay, round up. I think small mistake we have done because this should have come plus 1 0, plus 1 0. Then why it's not coming? 175, 12, 12, 175. So round up, round up. Okay, wait. Okay, okay. So this is one problem. See, if you interlink, if you write 3000 and all, it will create a problem. So always try to interlink it shorter, no? So I should take longer one. Now it should come correct. Yeah, 17. Okay. Because manually I'd input 3000, no? So obviously Excel sheet will not work out. So always try to interlink that. This, it has to be interlinked. Okay, great. Now it is 17, 17. And I think, yeah, here also there is a mistake. See, here also 3000 manually I had written. You should not write. You're finding along shorter, no? So to take the longer span. Spacing you're finding, no? Yeah. And here also, it should not be 3000. Okay. You're finding the shorter, longer, no? You have to take shorter. That is P. Now it will be, now it is correct. Here also, you have to take, fine. Now here it is correct. Okay. Anyhow, let me make it clear. I have taken shorter span. If I'm taking shorter, I have to take the longer one. Okay. Longer I have taken, correct. And if I'm taking the longer, I have to take the shorter. So shorter will be, yeah, shorter will be C. Yeah, so correct. B and this is C. So, okay, fine, good. Done. Finish. Your answer is ready. Only the thing is what change you're supposed to do, no? This answer will come in 10 diameter, which is actually wrong because we're making use of 12 diameter, no? So in that case, what you do, you strike out the answer, you delete this, you delete this, you delete this, you delete this. Why? Because it is 12 diameter, so your answer should come in 12 diameter. So what you do, you just come here, say plus this total cutting length, you multiply this total cutting length with weight of 12 diameter, which is 0.888, and hit the enter button. Finish. So 58.35 kg of steel is required. Similarly, here also you are supposed to do same thing. 65, multiply this by 0.88. Okay, fine. Similarly, here also plus, click on this and multiply by, again it's a 12 diameter, so 12 diameter is 0.888. Enter. Similarly, here also this one multiply by this one, enter. Got it? So this is the right answer what you have got. Got it? So if you want, you do it manually and check the answer what you have got. You'll get the same answer. So that is the easiness of doing a Excel sheet. If you prepare Excel sheet in this way, you can take out all the quantities. Yeah. So one I've explained. Similarly, rest you try to do on your own because now you are in such a position where you can do all these things. Okay. Similarly, try to do it. I always tell, if you're working for the first time, do it manually. Then do it on the Excel sheet and try to verify the answers. Only then you'll have a confidence in that. Okay. Now try to do for the other thing also. All these things you try to do on your own. Okay. One assignment is done. I'll go to one more assignment now. So one more assignment is this one. Okay. Say I won't be sharing this drawing since these drawings are not to be shared. Okay, they're confidential drawing. Only whichever is shareable, I'm going to share. Okay, don't ask for all this drawing. Only thing is what you do, you just take a screenshot of this. If you are interested, take a screenshot. Now here, all the footings are given. Here you just concentrate on the reinforcement details. Again, same thing. Here S1 and S2 is mentioned. S3 and S4 is mentioned. What do you mean by this? The meaning is very simple. This you consider as a shorter span. This you consider as a longer span along the bottom. Again, top reinforcement. Again, this you consider along the shorter span, and this you consider along the longer span. Okay, if not in that way, usually what you can do is you can check the cross section of the footing. See, this is a cross section what is given. Now if you observe here, see where it is mentioned. So your S1 is S1 and this is S2 they have written, and this is S3 and this is S4 they have written. Okay, so how do you understand this? So it's a cross section what they have given. So you can consider your S1 to be your distribution bar and S2 be your main bar. Similarly, on the top, this S4 is your distribution bar and S3 is your main bar. Okay. Yeah. Sorry. S4 is your main bar because see, bottom shorter span, bottom longer will come. Again, in top, shorter span, and inside that will be your the distribution bar. The main reinforcement will be at the top, but whereas in the bottom, the main reinforcement will be in the bottom. In the top, your main reinforcement will be the top. After the top, the bottom next to the top. This is top main bar. This will be below that. But in bottom, this will be main. Over that, the distribution will come. And in the top, this will be main. Below that, the distribution will come. Okay. So in the top, this will be my main reinforcement. And this will be my distribution. In bottom, this will be my main reinforcement. The dotted is a distribution. Okay. Fine. And for that, they have given it here. If you don't understand from there, they have given it here also. So how they have given, you can go through this drawing. So yeah. So this is typical. They have written like this is S1. Where is S1? This is S1. Okay. This is S2. Okay. And this is why it is dotted. The dotted indicates it's a top reinforcement. And S4 is top. S1 is bottom. Okay. You're getting my point. Okay. Usually if you don't understand, whenever a drawing they mention dotted, it means it is in the top reinforcement. They mention it as, they put it in dotted line. Okay. That is a typical way of doing a structural detailing. Okay. So this is S1 and S2. And then based on that, you can you can, check this thing. Come to the footing reinforcement. Anyhow, it doesn't matter to you. You just take out the quantities if you are interested to take. Okay. So you take this as shorter span. You take this as longer span. And then you top, you take this as a shorter. You take this as a longer. Okay. Very simple. And anyhow, it's very simple also. See, this is 125, 125. It is 150, 150. Right. Again, it is 175, 175. This is 150, 150. 175, 175, 150, 150. Okay. 125, 125, 125, 125. Got it? Just in case you take a screenshot of this, try to do the BBS for this. If you have any doubt, get back to me. I'll solve your doubt. Okay. Again, even though this is a isolated footing, this CF means combined footing. Even though it's isolated footing, again you get a bottom reinforcement and top reinforcement because it's an industrial structure. In industrial structure, you get such kind of reinforcement. Okay, 2 assignments are done. Next, we'll go to the third assignment. Okay, see, it's totally up to you whether you want to do it or not. If you are okay with the concepts, you don't have to do that. That's it, simple. Again, here also same thing. Footing schedule is given. Bottom rebar in L direction, that means along the length direction, and bottom rebar in B direction, along the breadth direction. That means this is your shorter span, this is your longer span. Okay, that is why we have prepared the Excel sheet in that way. Bottom and top, and along shorter span, along longer span. Okay, got it, no? Then the drawing is given to you. Based on that, you can take out the quantities. So this is a drawing given. Can you take out the quantities of here? Again, here you see same thing. Bottom shorter, longer, and top also shorter, longer, but it is given in both directions. It's understood. That means longer and shorter both are 12 die at 180, 180. Okay, great. So you can do the quantity estimate, I mean BBS for this particular footing also. Try to do a 1 or 2 footing so that you get an idea. Okay, fine. Next, in the same way, I'm taking a lot of drawings. You take a screenshot of this because these drawings are already shared with you. This drawing is shared with you. This drawing is also shared with you. This drawing I cannot share. You can take a screenshot of this. Okay. Don't ask me for this drawing because those I cannot share. Even this also I won't share, but you can take this thing. What is that? Screenshot of this. You note down and you can do the calculation. Then if you want me to verify, you send me this Excel sheet and I'll verify it. Okay. Yeah. Bottom bar, top bar. Again, same thing. So bottom main, this is TRNS. This is what is TRNS? Okay, I don't know what do you mean by TRNS, but actually it's a distribution steel, main bar and distribution, main bar and distribution. Okay, it's understood. You can do for this also. Okay, then after that, yeah, I had taken one drawing where I'd explained you this thing, no, which is that slope footing. For the slope footing, if it's a slope footing, also same thing. BBS won't change. Only in the estimation it will change, whereas BBS remains the same for the slope footing also. So for the slope footing, they have mentioned it here. You can do this, no? See, footing F1 and F2 is given. Forget about all these things. This is not required. When you come to the BBS, this part is not required. Okay. Only we are concerned with the steel. So it's written here. B1 at CNC, B2 at CNC. That means this is along the shorter span. This is along the longer span. In the shorter span, you're supposed to use 12 diameter at 150 center to center spacing. Along the longer span, also you're supposed to use 12 diameter at 150 center to center spacing. For F1 footing, how many numbers are there? 16. F2, there is 8 number. You're supposed to use 16 diameter at 150 in the shorter span, and you're supposed to use 16 diameter at 150 in the longer span. Pretty simple. If you want, I can do this for you. I'll go to the Excel sheet and let me take one footing. I'll take this particular footing. I'll go here. Okay, I'll do it here. Fine. Quickly tell me what is given there. Yeah. So I can do it in this way. So I'll do it in this way. Okay, I want the size of the footing, which is 2300 by 2300. So let me input that 2300. Okay, 2300. And this is also 2300. Okay, done. Then, yeah. So this is done. Next, I want this thing. So it's a what is the depth of the footing? Okay. So in the depth, what you're supposed to do, the depth of your footing, it will be your overall depth. Oh yeah, overall depth. This depth, not the overall depth. You're supposed to take this depth in case of this footing. Yeah, this you may have a doubt. Yeah, see, when you're doing this slope footing BBS, your D will be only up to this depth. Okay, because your L will go only up to here. Okay, so you have to consider the D2 one, not the D1. D1 is overall depth, that is not required. Your L shape will be bent only up to here. So take D2 dimension. Okay, so for the D2 dimension, we'll go back to that again. So D2 we'll find from here. So we have to take D2, which is 200 and 200, both the case. So again, it is 200 for us. So I'll take 200. So depth will be 200. Okay, I'll change according to that. So this we can round up. We can make it as yeah. So you round it up since it is coming in this point. Round up and comma 0, close the bracket. Okay. So error is because of the bracket. So give one open bracket. Now it will be okay. Fine. 67, 67. Got it? No, you know when it comes in decimal, try to change it. Yeah. Finish. Now come to number of bar. How many F1 footing are there? There are 16 F1 footings. So come here, make 16 here number and make 16 here. Finish. Again, then diameter. You're supposed to make use of a 12 diameter at 150. Okay. So this is along the shorter I'm doing. First this one, 12. Okay. And spacing is 150. All right. Spacing is 150. And see, this is shorter span. Okay. So shorter I've done 12 at 150. Next I'm doing for longer. So longer I haven't changed. So in the longer it is mentioned again 12 at 150. So here you change it to 12. Yeah. You make it 12 and this is 150. Got it? Done. Finish. Once you do all this update, finish. Your answer is ready. Your answer is ready. What is the answer? Simple. Your total cutting length will be 2200 plus 67 plus 67. Okay, I haven't done the bend deduction. If you want, you know the concept now. Bend deduction, if you want, you apply it. If you want, let me apply minus 4 into, which is that? This one, 12 I'm supposed to take. Okay, done. Here also, if you want to apply bend deduction, minus 4 into 12. Done. Okay, fine. And total cutting length will be how much? How much cutting length? 2.286 is the cutting length of one bar. Multiply by number of bar. Number of bars I'm getting 16 into 16 I have to do because there's 16 F1 footing. Okay, got it? So totally it will be how much? 3. Now one change should happen. Always remember, because I'm finding a weight of a 12 diameter bar, but my weight is coming in 10 diameter column. So this I should delete. Okay. So when you do this, this is one problem. You come in the 12 section, right? Plus this multiply by 12 value. Enter. Finish. Your answer is ready. Plus this one multiply by 12 value. Done. Finish. So this is a total steel that is required. If you're putting a F1 footing of 1200 by 1200 by 400, having 16 numbers according to this particular drawing, okay, according to this particular drawing, then your BBS will be this much. Okay, when you give it to the bar bender, you have to tell cut this 2200, cut this 67, make this 67, 67, 67, 2200, and accordingly you try to do. Okay, and if you ask what should be the my total cutting length, you should tell you should cut your 2.286 mm of a bar. Out of that, 2200 will be your straight, this will be 67, this will be 67, and then the bend deduction is going to apply. So totally it should come out to this. Getting my point? So in this way, you're supposed to do the bar bending schedule. Okay, great. I think most of the things I've taken care of. Okay, and then again, I think it's enough. Most of the things I've explained you. Again, it's the same thing. If you want, again, not required. This is another. Again, I won't share this drawing. Again, this is another industrial building, because whenever you find, no, this is actually isolated footing, F1, F2, F3, F4. If it is combined, it will be CF1, CF2. It's isolated, but you're getting a bottom reinforcement shorter span, longer, top reinforcement shorter, top reinforcement longer. Done. If you want, you can do BBS for this also, so that you don't have any doubt. Now let me go to few of the industrial projects. Again, same thing. This was one of the projects which I had explained you in the quantity estimation time. Right now, see, this is BBS. If you can do, very simple, we can do the BBS. Same thing. Just I'm showing you just for your understanding. Okay. Yeah. Again, same. Bottom face, shorter side, longer side, 16 at 150, 16 at 150. Again, top face, shorter side and longer side. You can do the BBS, very simple. What you're supposed to do, just take that value and you have to input that in the this particular area, this particular thing. Okay, because you have a bottom, you have a top reinforcement. So this you can do, no? You can take a screenshot of this, and if you want, you can solve one or two problems, so that I'm trying to, touch all the drawings. This is another industrial project. Okay, because industrial projects are a little bit complicated. That's it. This is one more. I think, yeah, this is another commercial building, a very big commercial building. I won't share this drawing. Okay, because few things I have shared, I already told you. And then don't message me for the drawing. Those drawings which are shareable, I'm going to do, because all these things is not required for you. Whatever is required, I'm showing it here. Okay, you can take a screenshot of this. Yeah, you can take a screenshot of this and you can take out the quantity. Okay, again, see here. Yeah, see here, F1, F2, F3, F4, this is your isolated footing. F5 is also your isolated footing. F8, F9 is also isolated footing. Okay, and here what has happened, I'll tell you. See, this much footing, F1 up to F3 footing, this is your isolated footing, where you have reinforcement in the shorter span, that is bottom reinforcement, and longer reinforcement you can do. There is no top reinforcement here. F1, F2, F3 same. Similarly, your F8 and F9. F8 and F9, this is also isolated footing, where you have a shorter reinforcement in the bottom, 12 at 100, and 12 at 100 in the longer span. These things you can do. Whereas this F4 footing you see, whereas this F4 footing and your F5 footing, this is not your, this is also isolated footing, but these people have bottom and top reinforcement. Now you see how these people have mentioned it here. F4, they have given reinforcement 20 die at 125 center to center spacing. This is bottom in the shorter span. 20 at 125 center to center bottom in the longer span. Now he has mentioned top reinforcement. So in the top, you are supposed to provide another 12 die at 150 in the top along the shorter span, and 12 at 150 in the longer span. You can do that. No? Very simple. You have an Excel sheet ready, or you do it manually, you get the answer. Similarly, F5 also same thing. 20 at 125 along the shorter in the bottom, 20 at 125 along the longer in the bottom. Now for the top, they have mentioned it here. 12 at 100 center to center spacing in the shorter span, and 12 at 100 center to center in the top. Okay, pretty simple. Done. These things also you can do. Now I'll go with another footing. This is also another industrial building. Now similar. F8, F9, F10, everything is given. Bottom shorter, bottom longer, top shorter, top longer. You can do it. And I'll go to one of the commercial building. Yeah, this is another commercial building. Okay. So I've taken care of all the buildings, commercial, industrial, house building, everything I've explained you. So this is commercial building. Here what has happened? This F1 footing, F2, F3, F4, all these are your isolated footing. How did I say that this is isolated footing? Very simple. Forget about everything. Come to the reinforcement part. Okay. We should always concentrate on the reinforcement part. So this is your reinforcement part. Concentrate here. Enough. So what is written? Bottom and top is written. Fine. So only the bottom is showing, that is 12 diameter at 150 center to center spacing. Okay. This is also 12 at 125 center to center spacing, 12 at 100 center to center spacing, 12 at 100 center to center spacing. He has written only bottom, but he has not mentioned whether it is shorter or longer. If they are not mentioned whether shorter or longer, it means both ways. shorter and longer, you have to provide 150, 12 at 150, along the shorter, along the longer. In case of F1, F2, F3, and F4. Got it? Because there is nothing mentioned in the top. Now, when you come to the ice combined footing, CF1, CF2, CF3, 4, 5 means it's a combined footing. C for the combined, F for footing. So here you will get bottom reinforcement and top reinforcement. So in the bottom, you're supposed to provide a 16 die at 150 center to center, along the shorter, along the longer. And in the top is mentioned 16 die at 150 center to center, along the shorter and along the longer. Got it? In this way, CF1, CF2, CF3, CF4, and CF5 you're supposed to do. Got it? So in this way, you can take a screenshot of this. If you're interested, you take out the quantities of this. Okay, very simple. If there is bottom and top mesh, use this Excel sheet, the last one, this one. This will solve your answer. If there is only bottom reinforcement, then use any one of the Excel from here. Your answer will be ready. And make sure, because here whenever you get the answer, steel answer, make sure to change it. Suppose if it is 12 diameter, it should come in 12 column. Okay, later I'll explain you one more way, not now, maybe once I finish all the lectures, I'll take you to a few of the advanced topics of the Excel where you don't have to change this. Right now you change it, but later I'll tell you one method where you need to apply the coding, if formula, if while and all. There you don't have to change. The moment you insert 16, automatically your answer will come in 16. The moment you enter 20, your automatically answer will come in 20 dia column. 20, 20 call. I mean, this particular row. Right now, you will not do that. Right now, you practice this method. Later, once I finish all the BBS part, when I go with the Excel calculations, I'll add one lecture where you can make use of that formula, because you need to write here. Okay, if and all you need to write. We'll do that later so that you don't have to change. So that comes under the advanced part. Right now, you finish these things. Yeah. So I hope I was able to explain most of the things, and I've covered almost all the drawings here. Okay, industrial, residential, commercial, and all. So everywhere I taught you how it has to be done. The concept remains the same. Only the size of the footing will change, and only the diameter and the spacing is going to change. Rest the method remains the same. So we'll see you back in the next lecture. Thank you.